Hello and welcome to the Introduction to Scripting webinar. My name is Rima Malik. I'm a technical consultant here at Psychology Software Tools. And this is a recorded webinar so that you can go back and rewind as well as follow along at your own pace and pause the presentation at any time. And before I actually get into the actual scripting portion of the webinar, I want to just go over some ways that you can get in touch with us here at PST. So we are on all the social media sites. The one I want to point out is the PST Net channel on YouTube. This channel on YouTube has just a bunch of videos that display different features of EPrime and how to set up various things in your experiment. So we definitely recommend checking out the YouTube channel and the videos we have available as an added resource to help you with your experiment design. We also like to always bring up our website. If you're not familiar with it, it is pstnet.com. And when you pull up this website, you will see all of our product information. And if you actually want to get in touch with us, if you need assistance with your experiment or any questions you may have, you can go to the support tab, and under product service and support, it will actually link you to our YouTube videos as well as some other information. And then if you want to submit a support request to talk to a technical consultant, you can do that here. And we actually recommend the quickest way to get in touch with somebody is to actually log in. This login link will basically ask you to register your product information, such as your serial number and your email and things like that. And that actually registers you as a user. And once you're registered on our site, it's easy to get in touch with somebody. And we actually recommend attaching your experiment, the ES2 file, as well as any additional files to run the experiment. You can actually attach that to your ticket. And that helps with, then we'll be able to actually run the experiment on our end and take a look and help with anything that you may have questions. So, take a look at our support site, and you can also link onto some of the knowledge base articles as well as sample experiments that are available. Now, before I start into the actual scripting portion, today we're actually going to design some experiments together, some very, very basic ones. There's about 5 different tasks we're going to do, and they're going to each get a little bit more difficult or a little bit more comprehensive. The first thing that actually kind of is the foundation of scripting is scope. If you're not familiar with this, there are levels in the experiment. So you can see here it's kind of your session procedure is the first level, and then it kind of goes down to the block list as well as the trial list. This is kind of by default what we do in our experiment design, is have these 3 different levels. And you can also add additional levels or delete levels as well. This is the easiest way to design your experiment as well as to track how the data is logged when the experiment has ran. So the user's guide available with EPrime goes into a lot of detail about scope. Basically, when you're trying to resolve something in EPrime, it can search at higher levels but not lower. So if EPrime is searching for something that's been set, such as an attribute, it will have to look up for it. So you want to make sure that it's been set in the higher up levels. There are, as I mentioned, 3 default levels: the session, block, and trial. Of course, you can add your own levels as well. And the values, basically the way you get the values, can be set as well in the startup info or in the global scope as well, which we're going to talk about in a little bit. So as I mentioned about attributes, we're going to kind of just talk a lot about 2 terms that are important in EPrime, which are attributes as well as variables. Now, attributes are actually, they are logged to the data file, and variable is a different thing that deals more with script, but this is a major independent or control variable that you set in your experiment. So you can see here in this list object, they've set text as an attribute as well as correct answer. There's quite a bit of stuff, basically anything you can set in here. It could be the color, the image, anything that any stimuli you're showing. to the participant could be set in the list object, and that would be referenced as an attribute. Another way to define or set an attribute in EPrime is the startup info editor. So you are probably familiar with running an experiment, and in the beginning it's prompting the participant to enter their subject or session number. This information in the startup of the experiment is logged to the data file as an attribute, so these can actually be referenced at any time in your experiment. So if you want the participant to be prompted to enter their name or their sex or their institution or any specific parameters that you're gathering or any demographic information that you're gathering, that will be available for the rest of the experiment because it's been logged and set in the startup info editor. The object properties, the reason I reference this is if you're familiar with the interface of EPrime, you can actually go to the property pages for each and every object that you put in there. So if you put text, if you put a list object, if you put movies or images, all of those things have their own property pages. And there's quite a bit of stuff that you can do in the actual interface. You can adjust the frame, the font, the duration of the object. You can adjust the logging of the data that's set for that particular object. All of these things are referenced here, and the important thing to remember is you can customize your experiment and reference these objects in script as well. So if you want to actually further customize or have some very specific properties for the object, you can actually use script to kind of customize your experiment, but the interface allows you to set properties as well. The next thing I want to discuss is generate PreRun. There are two important features in EPrime that help with the timing of EPrime. As you may know, EPrime is very kind of keen on the millisecond accuracy, and timing is very important. So whenever you set an object or a procedure, you would want to set the properties correctly to have the best timing. Now with generate PreRun, this is a property that's available underneath the procedures. So you can open up any procedure, such as this is the session procedure, but any procedure in your experiment and go to the property pages. There'll be two tabs, and you would want to go to the common tab, and there it will talk about script generation. And we're actually going to set these properties when we design our experiment as well. It's just good practice because when you have script in your experiment, you want to make sure that before object run is selected. The other option in this particular property is top of procedure. Now top of procedure means that the script in that procedure will generate at the beginning of the procedure. So all the objects will start loading and generating in the background of EPrime so that they're ready to kind of pop up on the screen. Now that's great for timing. It kind of avoids the delay of loading the object. But if you have script, you don't actually want the script to generate at the beginning of the procedure. You want it to generate right before it's supposed to run. So the best practice is to have before object run selected when you're using any script in your experiment. This is just an important thing that you would want to make sure is set correctly, just to avoid any design issues. The other feature we have that deals with timing is pre-release. Similar to generate PreRun, this allows the object in the next, basically the next one in line on the procedure to load in the background. So it allows that object to pre-release, and it kind of gets ready in the background of EPrime so that it's ready to go and it can kind of avoid any delays. But similar to generate PreRun, you actually don't want pre-release to be set if you're using script. So this is very important, which makes sense. You'll see later that if you have an object that's changing or customizing something in script, you don't want it to be loading in advance because that can cause some type of design issue with the object that it's referencing. You want it to load when it's supposed to load. So allowing pre-release would cause issues. So just make sure that's set to 0 if you are using script in your experiment. And these both generate PreRun and pre-release. We have articles on our website, so under knowledge base you can search through and find these properties, and they talk in the article about these as well if you would like some more information. Also, it's important to make sure you save your work. That's just, of course, in any computer program you want to make sure you save constantly so that you don't lose your work. And before I start into the actual scripting process, a little background about scripting in EPrime. Scripting is basically writing commands to an existing program like EPrime. So if you're not familiar with computer programming, a program like EPrime has already been constructed with a ton of code and script. The developers here have developed this just amazing interface that's user-friendly, where you can just drop objects and design your experiment, and the coding is already in the background and has been implemented for you. But of course, you can also have your own commands and do your own customization by adding some script on your own. So EPrime is made out of its own code, and like I said, you can add some to supplement any object properties and do different functions in the experiment as well. And EPrime understands EBasic, so EBasic is the programming language for EPrime. And EBasic is designed to be friendly for beginners. It's actually based off of VBA, so it's based off of Visual Basic for Applications. So if you are totally new to that, we recommend, of course, our resources for EBasic, but you can also kind of read up on VBA. I know they have VBA for Dummies. They have a lot of books available to kind of teach you from the bottom up about scripting. So if you are interested in having a very customized experiment and you want to play around with script, I recommend reading on into that as well. Learning a script, we look at it as basically learning a programming language is similar to learning a new spoken language. You have to first learn some conventions as well as concepts, and then you build off of that. Then you start learning how phrases are constructed, such as the syntax. So you really have to start from the bottom, and bit by bit it will start to make sense. And the other thing we want to talk about here is the scripting process, which is this flow chart kind of shows you that it's thinking of it in logical pieces rather than some of it. So a lot of times researchers will just design an experiment and have a ton of script, and then when they generate or run the experiment, they'll get an error message and they won't really know where it's coming from. That's why we recommend designing or having like a hypothesis of what you're going to be collecting and all the information you want to gather, and then implement the first portion. So set up a few of your objects as well as any script that you may want to use to customize it. Even if you're referencing a sample experiment or if you're copying from another experiment, you want to make sure you first implement line by line the script and then test it by basically generating the experiment. Once you debug that and make sure there's no errors, you can kind of continue with the workflow and then implement the next portion. It's really important to do it bit by bit, just because you don't want to get that error message at the end where you have no idea why it's there. Script is very important to kind of make sure that each line is set up in terms of syntax and everything else first, and then build off of that. So this is what we recommend for the scripting process. These slides kind of go back to the scope of EPrime. As I mentioned, these are where attributes can be seen when they're set. So if you set something in the session procedure, you can actually reference it anywhere below in the experiment, because EPrime, as I mentioned, it'll look up for the attribute. So if you reference the color down here, let's say you put some script about if red is shown, press 1 or something like that, you want to reference the attribute color, then you want to make sure that the color attribute is set above. And of course, if you use anything in startup info, such as the subject or session number, that'll be available throughout the whole experiment. So it's already in there if you want to reference subject number 1 or subject number 2 or all the females or all the males. That kind of information that was collected in the beginning of the experiment will be available. And then here, if it's in the block list, of course, it's available below, and trial list, it's available below. So if you want to reference something up here that's down here in the stimulus slide that's set here, you won't be able to reference it. You have to have it above in order for EPrime to find it. This just talks about where you can get the values at runtime. So when the experiment is ran, this is the way that it will resolve the reference of the attribute. And these are just some of the points that I just talked about. EPrime understands EBasic, which is our programming language, and it is based on VBA, as I mentioned. And we have EBasic Help available in our Help tab in eStudio, and this is the repository of all things scripting in EPrime. And we will open that up quite a bit today to kind of just look at some scripting, basic scripting things. And as I mentioned, the best practice is to use the generate and debug method for implementing script. So make sure you set up a little bit of script and then generate it, kind of check out each line by line to make sure it's set up correctly. And then of course, if you have any error message that you have no idea why you have it, or if you're just having trouble with even just a little tiny bit of script that you've added, feel free to get on our site, register, and just shoot us a support request, and we're more than happy to help with any of the questions that you may have. So the way I've designed the presentation today is we're going to have a first slide that kind of just goes over the general topics that we're going to cover, and then I'm going to break up each topic, and we're going to design a little tiny experiment together to demonstrate the topics that we're trying to show with script. I also have a few questions that will be covered in each topic, and then once we've designed the experiment and covered that information, I'll go back to that slide and we'll answer the questions. These slides are available to you as well, so you can reference them at a later time if you're wondering about a certain topic. In addition to the experiments we're going to design today, of course, there are a lot of sample, as I mentioned, a lot of sample experiments on our website. And if you're confused about where to find them, if you just send us a support request and say, hey, I want to collect this type of data, or I want to do this type of research, a consultant can actually send you some recommended sample experiments and kind of just link you directly to that information. So the topics today we're going to talk about, this is very, very basic scripting in EPrime, so kind of starting from the bottom up to give you an introduction to it. The first thing would be changing a property of an object using script. So I talked about how you can actually set the properties in the interface directly on the object in the property slides, or you can actually do it with some script as well. The next topic would be beyond the GUI properties. So you might be wondering, what is this GUI? GUI, which we reference as GUI, is just abbreviated for Graphical User Interface, and that's actually the workspace that opens up with EPrime. So that actual eStudio that's been generated and kind of prepared by our developers, that's the GUI interface. And it's basically adding, this topic is adding functionality with attributes in script. So an attribute, as I mentioned, is something that you can log at the beginning, such as the gender or the right-handedness, left-handedness. It's also something you can set in list objects later, such as the stimulus or the color or the images that you show. All those attributes are available in the data file. But you can play around and kind of add some functionality with these attributes by using script. The next subject is temporary storage of values within script using variables. So variables are not stored to the data file the way attributes are. Variables are kind of in the background of EPrime. They're something you set only in script, and they're available to help you with some various statistics that you may want to collect or do some customizing behind the scenes. And there are some different variable types we're going to cover. Debugging is also something we talk about. You would use debug statements to set error messages or to get the value of the variable while the experiment is running. So these are advanced error handling techniques that if you want to make sure that there's no problem in your experiment, or if you want to see what a value is of a variable during the experiment, there is some debugging statements you can set. And then we're going to look at if-then statements, some loops, and go-to statements in script. These are kind of general scripting things that I would say are pretty common. So we'll talk about those as well. That's kind of more of the advanced portion of the presentation today. So the first topic I mentioned we're going to talk about is changing an object's property using script. So the first question is, why use comments with EPrime scripting, and how do you set them? Comments are a very important part of scripting in EPrime. And then how can you change an object's property in script? So now I'm going to get out of the presentation and open up actually a blank EPrime experiment. So I'm just going to go to my computer and find eStudio, because we're actually going to develop the experiment using eStudio. And I'm going to open up just a blank experiment. Now you will notice that I'm prompted to use professional. I'm actually using the professional version of EPrime. If you have standard, that's perfectly fine. You can follow along. Some features may be slightly different, but it's pretty much the same. And the version of EPrime I'm using is the EPrime 2.0.10.356. So that's the latest version of EPrime, and if you want to update your version on our website, you can actually register and log on, and you can update to the newest version of EPrime that I'm using for no additional charge, as long as you are a registered user on our site. So once you've registered your product information, you can go to the Downloads tab, and you can find that 356 EPrime SP2 link and download the latest version. Now, if you have standard and you're interested in getting professional, you can contact us. Our website does show the differences, the features that are available in professional, so you can look on our website for that information. But like I said, you will be able to follow along and design as well by using professional or standard. So I'm going to open this up as a professional experiment. And the first thing I want to point out is if you do go to the Help tab, you'll see EBasic Help is right here. We're going to open this up quite a bit today. This is the repository of all the scripting, and you'll see there's quite a bit of information in here. And each article actually gives you a syntax of how to write it, a description, comments, and an example. So there's a lot of information in here that's very helpful with scripting. A lot of times our users will find something that they need and copy and paste the example. Of course, you want to make sure that with copying and pasting that you are debugging, generating and debugging it, making sure that each portion of the script is set correctly in your own experiment, because a lot of times you'll have different object names and different things that are referenced. So it's kind of a good resource to look at the examples. Copying and pasting can sometimes be confusing because you want to make sure you have it set correctly with what you have in your particular experiment. Of course, Help also goes into the documentation. As I mentioned, the user's guide has a lot of information. It's kind of like the manual of EPrime. We also have a getting started guide, which is kind of an abbreviated version of the user's guide. There's a lot of nice pictures as well as detailed information in all of these resources. About eStudio is actually what you can click on if you need your serial number. If you need the serial number of your EPrime product, or if you need the version of EPrime you're using, when you register on our site you log in as a registered user, if you're not sure what your version or your serial number is, you can look here for that information. So we're going to actually just design a very basic experiment, and I'll title this Changing Object Properties, and it's an ES2 file. So now that I've saved that, I'm going to actually start designing the experiment. So in my session procedure, I want to start with an instruction slide, of course. I'm going to drag and drop the text display, and I'm going to change this to instructions. And since we're focusing on script today, I'm not going to really be too detailed about what's written in the actual interface, because we just want to make sure that the scripting is set up correctly. So this slide will just show welcome for 1,000 milliseconds, and then it will go away, so that's fine. And now the actual block list, I'll drop it right after the instructions, and I'll call this block list. And you'll notice I'm using the same setup as the three different kind of levels that we talked about. You want to have these levels set up so that it's easy for you to add and delete anything that you may want to later. A lot of times, researchers will want to run a practice trial and then run a test trial. So adding those levels is easy with this setup. So I'm going to create a block procedure. And I'm going to then open up the block procedure, and I'm actually going to add a trial list. This will be the main kind of bulk, kind of meat and potatoes of the experiment. And I'm going to open up my trial list and reference a trial procedure. This is what the actual stimuli is going to run off of. This is the main procedure, is the trial one. And I'm going to actually just change the weight to 3, meaning it's going to run 3 times, just so that it's not only running once. And then I'm going to now open up my trial procedure, and I'm going to add the actual slides that will be shown. So first I want a fixation, because a lot of times you want a focal point or a fixation for the participant to kind of focus on the screen. So I'll do a little plus sign there. And then with the properties with this, I don't really need to do much. I just want it to be shown on the screen and then disappear, just so that the participant can fixate on this little cross. Then I'm going to now add a stimulus object. So you can either use a slide or you can use a text display for this, because we're not really doing anything fancy with videos or pictures or anything like that. I'm going to call this the stimulus slide. And I'm going to open this up, and in here I'm actually going to write this text will not appear. And in a second you'll understand why I wrote that. And then the next thing I want to do is add a goodbye slide, and I want to do that on my session procedure so that it's after everything has ran. So this will run 3 times because we set the wait to 3, and then I will just have a goodbye slide to close it out at the very end. And I'll just write thank you and goodbye. So you can definitely design this experiment while I am, and then at the end you can see, what we've done. But now we have the stimulus, and when it presents on the screen, it's going to say this text will not appear. Now what we want to do is actually change the property of this stimulus. We want to change something about it. So in order to change the stimulus, we want to change it, and we'll probably want this inline script to happen right before it, because obviously we don't want this script to generate after the stimulus slide. If it's something that's actually changed in terms of the property, we want that property to be changed before it's even presented to onto the screen. And this inline I'm going to call change text. It's important to have very specific names for all of your objects so that you can look back, or if a coworker is looking at it or a colleague, they'll know exactly what this script is implementing. Now I'm going to open up my change text, and just as a reminder, the reason I have it right here in between is because we want it to change something about the stimulus slide. Now if you're collecting some data and you want the participant to respond to the stimulus slide and then do something with the script will be after the object, and we're going to show that in one of the samples as well. But for today we're actually just changing something, so we want the script to be right before the object. So now we're going to actually add a comment, and as I mentioned, comments are very important. You can use comments for yourself, or just also for whenever others will be reading your script. And it's important to use comments to outline your ideas before writing script. So it's a kind of a way to explain what you're about to do. So our sample experiments, as I mentioned on our website, have a ton of comments in green, and those are just helpful to explain what each bit of script is doing, and kind of a great explanation for people that are referencing it. So you can write whatever you want here, because it will, comments will actually be ignored when they're compiled. So when that EBS2 runtime file is generated, the comments will not be taken into consideration. And the 2 different ways you can use comments is you can use an apostrophe and write the comment here, such as, what we're going to do, we're going to change the text that will appear on the stimulus object, and you'll see it's green. And if I want to do multiple lines, for multiple lines you can comment like this. So you'll notice it's black, it's not referencing this as a comment, so you would want to actually do a / and then like that, and then close it out, the asterisk, and then you'll see that the lines are all commented. So for multiple lines of comment, you want to do it this way, or if it's just one line, which is what we're going to have for this, you can actually just do the apostrophe. Okay, so we definitely recommend doing a lot of comments. It's just helpful to know what you're going to be setting. Now, to actually change the text that will appear on the stimulus, we need to first reference the stimulus object. So to do that, we're going to first write stimulus, which makes sense. That's the name of this object that we want to change or reference. And then you're going to hit dot, and when you hit dot, it basically brings up, it basically lets EPrime know that you're about to do something different. And we're going to see then that the script sense, which is the feature of EPrime, EBasic, that kind of shows you a lot of different concepts you can set. It gives you a list of things that you can reference for the stimulus slide. You can reference the reaction time, the onset delay, you can reference the color, the size, the text, a lot you can do with each object. But for us, we know we just want to change the text. So to change the text, we're going to go down to somewhere in here, text, and select that. So now we have stimulus.text. So text is basically the name of the property or the property in the object property that we're going to reference. So like I mentioned, you can change the text in the actual object, or you can reference it like this with script. And then we're going to set it to something different. And to set it or assign it, you can use this equal sign. Now, equal has two meanings in EBasic. You can basically use it for math. If you're going to do, using it for some calculation, you can do that in EPrime as well. But in this particular case, it's for assignment. A lot of times people use equal to assign something to something different. So we're taking the stimulus text that's in there currently, and we're going to assign it something new. And we're going to actually assign it to another string of words. So for string, you actually have to use quotation and type in what you want to be presented, and we will just say hello world to make it easy. And then you want to make sure you close it out with those quotes. If you don't do the quotes properly for a string, it will throw an error message. So you have to remember each and every bit of script is interpreted by EPrime, so you have to make sure the syntax is written correctly. That's why we always recommend, after just even a line or two, saving, generating up here, just making sure you don't get any error messages. So now we are just letting EPrime know, and if you wave your mouse over this, you'll see this script sense shows the text display object is derived from this, kind of explaining it, and then it explains that it's changed this to this string. So now we are done with that, and you can even we can even save it or generate it to just make sure that everything is set up correctly. And you'll see down here in the output box that there is an advisory message. Those are just kind of recommendations that EPrime gives in terms of better timing or better design, but they're not error messages. If we go to the Generate tab, it does say that the script compiled successfully. So that's what we want to see. We want to make sure that it's set up correctly, which it is. Unfortunately, I can't run the experiment on my end because I have the recording going on for the webinar, but I recommend pausing the presentation right now, going through and running it, just to show that this little tiny bit of script is actually going to change the stimulus in the background, and it will show hello world instead of what's written there. So I definitely encourage you guys to run that on your end. And the other thing to remember is that you have to know that you've now changed this for the rest of the experiment as if you had changed the actual GUI setting. And what that means is if later on you reference stimulus at some other part of your experiment, it will always now show hello world rather than what was written here. So once you've changed something in the script like this, it's always going to be changed no matter when you run it at a later time or anything like that. Okay, so now that we've done the first topic, we're going to go back to our slide and make sure that we are able to answer the questions that we had listed for this topic, which was changing an object property using script. So the first question was, why use comments with EPrime scripting and how do you set them? So as I mentioned, comments explain what each portion of script is doing. We use them a lot in our sample experiments as well. And it's just a great way to outline your ideas. It's also helpful for others to understand your experiment. So you'd be surprised at a later time you might want to reference this experiment years later, and you might be a little bit confused about what some script is doing. So it's important to have just a few lines, jot down a few lines to explain. And as I mentioned, it will be ignored when the experiment compiles, so there's no timing issues with comments, and you can set them either with the apostrophe or this way if you have multiple lines of script. And how can you change an object's property in script? Well, we talked about setting it by referencing the object's name. So we had actually referenced stimulus because that was the name of the object. You can reference any object in there. And then using the dot command to reference the list of properties available for that object. And a good thing to kind of remember is that you can reference any object in EPrime. You can even reference a list object, an image, a movie. So there's a lot of customization you can do with script. And then once you use that the dot command, it'll reference a bunch of things like text, accuracy, font. We looked at the huge list that's available, and we actually just selected text. Then you set it to something, as I mentioned with assignment. We assigned it to whatever you would like, and we actually used a string of words to hello world, and that allows EPrime to change what's currently there to show this. Okay, the next topic was adding functionality with attributes. So now we're getting into the important topics of attributes in EPrime. We're going to define what they are, and we're going to talk about how can you add them in your experiment. And then another thing is how do you reference them. So you've set them, but you want to play around or customize or do something with them, so there is a way to reference them later in the experiment as well. So I'm going to now open up eStudio again. And I'm going to just start with a new experiment because we want to build from scratch just so that it's kind of easy for you guys to follow along. And then if you want to design your experiment with us, you can do that as well. And I'm going to go to File, Save As. Let's name this Attributes in EPrime, or whatever you want to name it. And then we're going to start with building the experiment. And before I start, I want to mention that attributes are subject to scope. So what that means is if you're referencing an attribute, you want to make sure that it can be pulled from anywhere above it, as I talked about before with scope. And attributes are in the context object. This means context is actually a behind-the-scenes thing in EPrime. It's an object that you don't see in eStudio. So it's not something that you can actually see here, but this context object is referenced in script with like a little C. So C dot would be the context. And it stores the experiment data and associated routines, so attributes are stored to the data file. And by default, the object for context, as I mentioned, is referenced as a C in script. And if you want to read more about that, you can go to EBasic Help, but the context object is accessed via methods, so there's commands or functions that you can set up, and this terminology is explained in EPrime. I'm going to talk about this a little later, but methods in EPrime cause objects to perform certain actions, so you can use a set attrib to set an attribute and do certain actions as well. And then EBasic is there to help with setting up some of these methods and properties. Because some do require parameters, meaning there's some certain things that you have to set in order for the command to work, and EBasic will talk to you about what parameters you need to have in place. So let's first set up our experiment. It's going to be pretty similar, that we're just going to open up the session procedure and just have a standard instruction slide like we did before. And let's just call this hello and welcome. And then we're going to actually drop a trial list, or excuse me, a block list like we did before. And we could have referenced the old sample experiment, but it's kind of good to just build it together so you get familiar with the interface of EPrime. And I'm going to open up block procedure and drop a trial list in here now. And in the trial list is where I'm going to change something. I'm actually going to just have trial procedure here, and then I'm going to add a property, and the property is going to be stim text, because that's actually the stimulus that we want to show, the text that we want to show. So this is another way, rather than having it right on the object, you can reference it in this list object, and a lot of times users do that because you want to show multiple stimuli, so a list would be the easiest way to show multiple or do some randomization with the stimuli as well. We're just going to write in here, this text will not appear, similar to what we had written on the actual stimulus. But the reason we're doing it this way is because we want to reference the attribute stim text and change what's shown in this. So if you actually have a column of stimulus that you want to show, and there's a lot of different stimuli that you're setting in there, you can use this attribute reference to kind of grab this stim text column and change it and customize what's actually going to be shown. And then now we're going to have a stimulus slide as well. On the trial procedure, we're going to first have our fixation, of course, just like we did in the other experiment. And that's just going to be a little fixation point. And then we're going to add a slide and show the stimulus. And this we're going to actually reference using the attribute reference of these brackets. So if you're not familiar, in EPrime you can actually reference an attribute anywhere set by using these straight brackets, and EPrime will recognize it. So you'll notice when I first typed it with the left bracket, it popped up a list of attributes that are available. I can pull the session number, the subject number, which these two are referenced in startup of the startup info, which is the beginning that prompts the participant to enter subject or session. But we want to reference the stimulus text, which we've set in the trial list. So I'm going to hit stim text, and that recognizes that. And then I'm going to just add, you can add a keyboard, you can have them respond if you would like. You can do anything with that, but we want to focus mostly on the customization used with script. So in this, we're actually going to reference the attribute of stim text and change what's shown on the stimulus. So same thing as I mentioned before, you want to make sure that the inline script is right before the stimulus so that it actually changes it before it's presented on the screen. And I'm going to call this change text. Now the way we're going to change the text this time is we're actually going to reference a defined attribute from the list. We're going to grab one, we're going to actually set it differently. So before I do that, I want to open up EBasic Help, the repository that I keep talking about, and I'm going to actually pull up setattrib command. And this actually just talks about the syntax and what it does. And setAttrib is actually used to set an attribute in EPrime. So as I mentioned, you can set an attribute by doing it in the list object if you want to put color or stimulus text or whatever. You can do it in the startup info editor by what's prompted at the beginning of the experiment in terms of enter your subject, session, your name, or whatever you want to collect. And the other way, of course, is with script. And to set the attribute in script, you would use the c.setAttrib command, and you'll see that's in EBasic Help. And this is talking about a tutorial that's available that you can go through. And this talks about the setAttrib command is used to set the value of the delay as an attribute to be logged in the data file. So in this particular sample, it's using setAttrib to set a delay in the experiment. So there's a lot you can do, and you'll notice the syntax, it's using these strings and then setting it by writing it with this context. The other command that's available is c.getAttrib. Now these are the two kind of really important commands that are available for EPrime in terms of attributes. You're going to use them a lot, and getAttrib basically allows you to grab the attribute that's already been set. So if you have an attribute set in the list object or in startup info, you can grab it and change it or do whatever you want with it by using getAttrib. So there's setAttrib and getAttrib, and those are the two kind of very important things to if you want to change or add a new attribute to the context or update an existing one. And as I mentioned, these are the most common when referencing attributes. So in this particular example, we're actually going to just change the text using attribute references instead of properties. So we're going to first use the command of C. Well, let's first do our comments, of course. We want to change the text that will appear on the stimulus object, using an attribute reference. So this lets you know what you're doing with the script. And then the attribute reference we want to use is setAttrib, and you'll see when I hit C dot, it pulls up the options that I can do. GetAttrib is in here as well. You can get log information, you can get data file information. There's a lot you can grab, but I'm going to use setAttrib. I want to set something. So C dot set an attribute, and I'm going to set the attributes. And you'll see when I do the quotes, it brings up the same thing, the attributes that have been set already. And I'm going to use the stim text that was set, and I'm going to let EPrime know that I want you to set something else in place of that. And what I want you to set is hello world. So I basically let EPrime know that this attribute stim text, which is set up here in the trial list, I want to change whatever is presented in this specific attribute column, and instead of what's in that column, which is this text will not appear. I want the slide stimulus to show hello world. So this is the exact syntax of how you would want to write it. And then this string of words is of course in quotes, and then you'll see that it turns red, which is showing you that EPrime has accepted it. It's something that's kind of making sense. If you don't have the right syntax, as I mentioned, it will give you an error message. And then we'll just do a goodbye slide. So this is the other way that you can change some things in EPrime by using attribute references. And then of course you want to make sure that your properties are set correctly. As I mentioned with timing, if you go to the session procedure and then you click on the property pages, every single object and procedure have property pages, as I mentioned. If you go to the common tab, the generate pre-run is set to before object run, which is perfect. And I want to make sure it's like that for all of these procedures, just so it doesn't cause any issues with the script that's in there. And you'll notice with this one, top of procedure is set. What that means is everything in here will generate before the procedure actually runs. So right at the top of it, right at the beginning, it will generate, and we don't want that, so we'll just change this to before object run. And same with the actual trial procedure. You just want to make sure that generate pre-run is set to before object run. So I'm changing that as well, because you'll notice if you have top of procedure, all of these will generate in the background, and this inline script that's actually changing what's presented will also generate, and that can cause designing issues because we actually just want these to generate before they're about to be displayed so that the script can be taken into account and generate correctly to change the text that's on here. So just make sure those are set. And then the other thing, of course, is making sure pre-release on all of these is set to 0. So on the fixation, you'll see that same as duration is set by default. I actually want to change that to 0. What that means is the fixation will be shown for 1,000 milliseconds, but nothing will be generated or loaded in the background in terms of the next object. Because if we, same thing with generate pre-run, if we have pre-release set on here, the next object, which is this inline script, it'll start loading in advance if you have pre-release set to 100 milliseconds or something like that. We don't want that. It will cause some design issues, so we're going to just make sure that that pre-release is set to 0. Now, definitely encourage you guys to also save and generate and run this experiment as well. And if you have any questions, of course, you can send us a request. But this is pretty self-explanatory in terms of changing an attribute reference. And then the next portion, we're going to get into variables. So I encourage you guys to run this. You'll see how the attribute reference changes the stimulus. And of course, when you're trying to learn EPrime scripting, another thing is to kind of play around with various properties that you have. You can even just look at the reference of all the different attributes and things that you can change about each object, not necessarily the text. So you can just see the other options as well. Okay, so hopefully you had a chance to run through the attribute experiment that we just did. We now can actually talk about the questions that I had for this specific topic. And this dealt with the functionality with attributes. So the definition we have for attributes is that an attribute is actually subject to scope in EPrime, and as I mentioned, they're in the context, which is the C dot that we used in script. You don't actually see that in eStudio's interface, but it's kind of working in the background in the script, and it stores the experiment data and associated routines and is also logged to the data file. So that's kind of our definition there of attributes. Now, if you want to add an attribute to an experiment, as I mentioned, you can add or set them in the actual list object or at startup info, which is the beginning of the experiment. But you can also do this in script, and you can set a new attribute by using c.setAttrib, which is the command that we use to kind of change the stimuli text that would be presented. We set it as a new attribute. And then, of course, that will be logged in your data file. This also allows you to add a new attribute or update an existing one. Now, if you want to reference an attribute later that was already set in the experiment, you would use the c.getAttrib command. So now that we've talked about attributes, the next thing we want to talk about are variables. Now, these two things kind of go together, but variables actually are in the script level and are not actually in the interface, and they're not logged to the data file. So we're going to do some things with variables, and you want to keep in mind scope. So if you set a variable in the user script or in the beginning of the experiment, you will be able to reference that later in the script in the rest of the experiment as well. So the first thing we're going to do is actually set up an experiment, and then we're going to talk about what variables are in EPrime, and then we're going to create a counter in script to track specific values. So I look at variables as kind of like a bin, kind of a container for you to use in your experiment. They kind of hold important data or statistical information so that you can do math with them, or you can do various calculations as well as track various values. So I look at them as kind of in the background, kind of just holding information for you. And then if you would like it to be logged to the data file, it is possible by setting that in script. But by itself, variables are not logged, as I mentioned, to the data file. But there's quite a bit you can do with variables. One thing is counting, kind of having something to track a specific number. A lot of times people will want to track what trial they're on right now, or kind of see how many trials they've gone through. And then once the participant has gone through an X amount of trials, let's say 10 trials, they would change the experiment dynamics a little bit or show a different stimuli. So that's why having a counter to kind of keep track of how many times they've ran through the trials is very useful. So we're going to set a little experiment up that's similar to that. So I'm going to go ahead and open up another blank eStudio. And if anything is slightly off in the designing of the experiment, in the presentation that I'm doing, you do have a completed version. You should have a completed version of all of these tasks in your materials, so you can always reference the completed version that we've given you as well. So the first thing we're going to actually reference is the user script. This is important to know. If you go to View and Script, that's the way to access it, or you could do Alt-5. But the user script basically shows you, if you go to the Full tab, once you generate the experiment, it'll show just a bunch of coding in the background. Now, this Full Script tab is actually what the developers have used to kind of make EPrime, and kind of is the backbone and the development side of EPrime. So you don't have to do much with that script, but the user tab allows you to actually add anything that you would like to do to customize your experiment. So setting a variable at the global level is always a good idea, because it can be referenced at any point later in the script. And to do that, you basically would have to initialize or declare a variable. So if you go to EBasic, which is our little handy-dandy tool that I will keep referencing, and you put in the dim statement, this actually talks to you about what it does, and it does declare the variable and anything else you want to declare. And what that means is then it's available for you to use in your experiment or to kind of reference later on in script. So first we would want to actually use a dim statement in order to initialize the first variable we're going to use. To declare the variable at the global scope, as I mentioned, is great because you can actually use that later. So we're going to write here that we want to actually, I'm going to make my comment, that we want to actually initialize the counter variable in the user script, which is what we're in right now. So it will have global scope, meaning that I can use it at any level at any time in the experiment. To do that, I would use the dim statement, which you'll see EPrime makes it blue, meaning it's recognized that it's something is about to be initialized. And I'm going to use the trial counter. I'm just going to use a variable name that's pretty self-explanatory as to what it's going to be holding, as a long. And you'll see when I hit as, it pulls up automatically a list of things that I can actually declare that variable as. There's quite a bit you can do in here, and different data types that you can reference, but I am going to use a long. So that is in here as well. Or you could type it out as well. So now I'm going to just go ahead and save this experiment. It's always good practice to do that, and I'll call this the variables experiment, or whatever you want to call it, and then we're going to actually talk a little bit about the data types now. So if you go to the variable type, I believe there is information in our user's guide as well. Each data type is explained in the user's guide, but we also have them available in EBasic. So if you type in, we just set this as a long, so you'll see long data type shows up, and this kind of just shows you that a long variables, they're used to hold numbers, and this is the range that's available. So this is a pretty large range, and it also talks about how you can do math. So when you use this data type, you can actually do math on it. The next one I want to bring up is the Boolean. If you're not familiar, this is actually another pretty important data type, and this deals with the logical values of true and false. And basically, true is considered 1 and 0 is considered false. And by default, when this is initialized, this Boolean data type, it's set to false just by default. So you would have to set it for true or false, and that's one of the data types. The other one that's a really common one is integer. You're probably familiar with this. This is a data type used to declare whole numbers, similar to a long, but the range is a little bit less. So this, math may also be performed on these numbers. Whole numbers are in this range, but there is a little bit more of a limited range, whereas a long, which is what we've used, allows for more numbers. And the reason we like to just by default use long is if you're not sure how large your range is going to be, or how large your numbers are going to be after the calculation or the statistics have been gathered, it's best to use a long, because if the integer, if it goes over the range, or if there's an overflow, you will get an error message. So you want to make sure that you don't get that overflow error due to running out of space. So the integer can't do that. That's why it's better to use a long if you're not sure about the space or how many numbers will be referenced. The last one I want to mention is string, which we've talked about in another experiment, that it's kind of mostly just dealing with characters. It returns a string of length number consisting of repetition of the specific character. And basically a string data type, if you go here, is capable of holding a number of characters. So it can be a mix of actually words, numbers, or just a mix of both. The important thing to mention is the default when initialized is just two quotes like this empty. That's the default. So once you actually enter some information in here, then that's the string of words. And that's how you can reference that data type, by using a string. And the other thing, even though you can use a mix of numbers and words, you can actually not do math on the string. Math cannot be performed, but if you would need to do math on something that's in a string, you would need to convert it to another data type. And our user's guide talks about conversion types, ways to convert basically between the data types if you need to do that. So those are the different types of data types that we wanted to talk about and mention, the main ones. Now that we've actually initialized our variable as a long, which means that we can do math on it as well, we're going to be adding the trials, basically. That's why it's called trial counter. So we're going to be adding, every time a trial is run, we're going to be adding that to a bin called the trial counter to this variable. So it's important to use long because that's doing some mathematical things on there. So the next thing we actually want to do is add to the session procedure. We will actually first set our instruction slide as always. So we'll just do this and then open that up and basically just say, the same welcome to the experiment. I'm not really worried about the objects in these examples. We want to focus on the script. So we're going to then drop a inline script right before the instruction slide. And the reason we do this is because we're adding trials, and we want every time the experiment to run to kind of reset or initialize the trial counter. So we need to call this init counter, basically meaning that it's initializing the counter. So we've set in our user script, if you remember, we kind of declared or initialized that we're going to be using this trial counter as a long. So now we're going to have to establish the value of the counter before any trials have any trials run. So you start with 0 because no trials have run yet. So it's kind of just resetting or initializing that trial counter. So we'll do trial counter equals 0, and that's really all. You'll see that the 0 turns to red, meaning that it's referenced, kind of accepted that value, and then whenever this starts over, it will initialize and kind of set that value to 0. Okay, so hopefully you guys have added that, and then now we're going to actually do the same thing that we did before, in the sense that we're going to add our block list, and then we're going to add our procedure. You guys must be pros at this by now, setting this basic experiment up, and then I will be adding my trial list. And then on that, I will be doing actually 4 trials. So I'm going to be adding some levels. I'll add 3 levels to make it 4. And then we will call, of course, the trial procedure will actually run that, and I'm going to use that for default. I can actually fill the rest of these up by going like that. Okay, and the attributes I want to add actually for this are, I'm going to add, I'll call it text. And then I'm going to just write some words here. It's not really important, as I mentioned. We're just tracking the trial numbers here. We're kind of entering some variables. So whatever goes on with the attributes is not really our focal point in this example. So I'm just going to put a bunch of words, and then I'm going to reference the correct answer as well. So I'll call this correct, and then I will just put the correct answers in there. Now I will add my actual experiment slides to the trial proc. I'll start with my fixation, of course, as always, and then I will add my stimulus. So I'll do stimulus here, and then I'm actually going to have a feedback slide as well. So I'll drag this feedback display, and we will call that just feedback, if I can. Okay, and I'm just going to go ahead and save, just because we've done some experiment design and I don't want to lose my information. So the next thing after the feedback is actually incrementing the counter. So we've had the counter, this variable, it's set to 0 at the beginning, but now when this trial runs and it shows the word and it gets the feedback and all that good stuff, we actually want to collect the number of the trial. So now that the trial is over, you're going to increment the counter. So I'm going to actually set that on my trial procedure after the trial and the feedback have been given. So I'm going to call that increment counter, just so we know what's going on there. And I'm going to open that up, and of course with my comments I want to kind of just map out what I'm going to be doing. So now that the trial is over, increment the counter. So I'll do that by setting trial counter, if you remember that's the variable, equal to trial counter plus 1. So that just means that, okay, this trial has ran one time, it'll add a 1 to the trial count at that point, which in the beginning will be set to 0. So I'll add 1. And then the next thing we want to do is we also actually want to write it to the output window. So this is an important thing that I want to talk about in terms of actually allowing the number thus far to be kind of generated for you to see. So just kind of a recap is we've declared in the user script the variable at global scope, so it's available throughout the experiment, and then we've initialized it at 0 in the init counter. That means it's initialized at 0, and of course it's at the top of the session procedure, so that after everything has ran and it's restarting, it will initialize at 0 again. And the next thing we're going to do is we're going to let that kind of the number so far, so every time it runs, if you want to see the number, for it to be available to the output window, you would use a debug statement. So we're actually going to talk about debug by going to the help and user tab, the EBasic help, and if you type in debug, you'll see debug.print shows up. Now this talks about what you can do with debug. It's a command used to send the value to the output window. In this example in here, it's doing something with the value of a delay. So you'll notice down in this pretty long example, it's a debug.print delay. So it wants to see the value of the entire delay in the experiment. So that'll print out for you to see down here in the output window. Now for us, we just want to see, what's the trial number so far. So to do that, we would do debug.print, and you'll see when I hit dot, it gives you the different things you can also do. An assert statement that allows you to kind of check some things in your experiment if they're set correctly. But print, debug.print, like I mentioned, will give you that output in the box below. So this output window will have a value. So this is helpful for our trial counter. And we're going to do debug.print. And this is the thing that we want. We want the current value of the trial counter is, and then you do ampersand trial counter ampersand. And then you want to just mark it like this. That's the way that EPrime recognizes the trial counter. You have to use this connotation basically in order for it to concatenate correctly. So for concatenation, it needs the ampersand in order to access the variable name, which we have trial counter, and setting that variable name so that it prints out the current counter in the output window. So this is the way that you would write it. And as I mentioned, EBasic Help does have that example as well. Now debug statements are really important because we have other advanced scripting webinars that go into more detail about what you can do, but basically it allows you to look at error messages in your full script to find problem spots. So if you want to just check something constantly when your experiment is running, such as a certain value, or if something is missing, or if you're copying and pasting between labs or something like that, you can set up these debug statements for error handling, and it allows you to know what the problem is, and then you can fix it. It is a command method for the debug object. It's useful for getting the value of a variable while the experiment is running, as I mentioned, and then it is in the debug in the output window, and it's basically going to give you that number, the value down here. And there's a lot you can do with these debug statements. And the one thing we do say is if you have a lot of these, we recommend actually taking them out or commenting them out when you are running for data purposes. If you have some timing concern, because some of the debug statements can take 10 millisecond or something like that of a delay on your object. So you want to make sure that you take those out if you're worried about timing. But for us, this is perfect because we can get the value of the trial counter so far. Now what we actually want to do at the very end of the experiment is we want to save the data to a file. We want to know what is the trial count number at the end. As I mentioned, variables are not logged to the data file, but you can actually log them by setting something. So we're going to open up the session procedure because we want this logging of the final number to happen at the very end. We don't want the data to log every single time the trial runs. We want it to be after the entire experiment has completed. So we're going to call this the save counter, which means that we're going to actually save the information to the data file so we can access that. So save the final value of the counter to the data file. So to do that, we're going to use our c.setAttrib command. because we're actually setting an attribute here. And this attribute will allow, once you've actually used setAttrib, as I mentioned, attributes get logged to the data file. So once we set an attribute for the trial count, it will automatically log that in the data file. So we're going to call this, you can call it whatever you want, but we'll call it final count just to keep it very kind of easy to understand. And then, of course, we're going to close out those quotes and let EPrime know which attribute, which variable we want set, and that would be trial counter. So this allows you basically to see that you're setting an attribute called final count, which will carry or kind of log the value of this variable trial counter that we've been incrementing. So it's important to remember, if you want this value to be available for data analysis or anything like that, that you would need to take the variable and set it as an attribute. Okay, so I definitely, same thing, recommend saving, generating, running through it. I'm unable to run the experiment on my end because of the recording that I'm doing right now for the webinar, but you can definitely run that on your end, and if you have any questions, you can submit a request. But for right now, we're going to close out the variables that we've talked about and actually go through the questions that we had for this particular topic. So we talked about the definition of a variable, as well as some other information on setting a counter in order to track a value. And here I just kind of summed it up, that a variable is not logged to the data file and is a temporary storage of values only within script. So it's in order to kind of keep track of something or for mathematical purposes. And of course, if you want that to be set to the data file, you can do that as well. The main data types we talked about were the Boolean, which is true or false, the integer, which is whole numbers, and this is the range where you can do math on it. The long is what we used in our sample today, and that's a larger whole number and has a bigger range, so you can do math on that as well. Now the string is a sequence of characters. You can use words, you can do a mix of words and numbers, but it cannot perform math on it. The default is these two quotes, and if you would need to convert, the string data type if you need to do some math on that. Now to create a counter in script, we just kind of did this in the sample experiment. So to go over that again, in the user script, we used the global scope to declare trial counter, so that this trial counter variable will be available to reference later on, which is what we did in some of the other script in our experiment. So we initialized it as a long so that we can not, don't have to worry about the data or the range, and we can do a lot of math on that. And the value of the counter at start is 0, and then we're going to increment it, which we actually did by adding 1, and then we save that file to the data file at the very, very end by using an attribute of setAttrib final count attribute. So once you've, of course, used the setAttrib command and set final count, you can go to View and Attributes in your experiment and see the list of attributes available, and final count will be in there. This is going over debugging, which is what we talked about. As I mentioned, it checks for errors in the setup. It's not syntax handling, meaning it's not going to check necessarily the way that the script is written or how you've set it up in there. It's going to check for if something is missing, or if you want a value to be printed, or if you want a warning message. Sometimes you can put debug statements if you want to make sure that an object has a duration of 0 or pre-release of a certain specific time. If you want the experiment to continuously check those settings, you can throw a debug statement in there, and every time you run it, the debug will make sure that that stuff is in place correctly. It is useful also for getting a value of a variable while experiment is running, which is what we did to the output window. You can also print out warning messages to the output window, and then this is the concatenation. This is the way it's written in order for it to run correctly. So the last topic we actually are going to cover is going to be broken down into 2 experiments, because there's quite a bit of information to cover. And the conditional statements, basically, we're going to be talking about if-then statements, as well as logical operators in script, and then loops and go-to statements. So these are kind of the a little bit more script-intensive portion of the webinar. So I'll try to go as slow as possible to cover in detail how to set these up in script. So hopefully you guys had a chance to run the variable experiment and kind of see that output window that the number, it'll be incrementing the trial counter, and hopefully it will be printing it with the debug statement, and you'll see a number in the output window. For the next experiment, we're actually going to open up a new eStudio, and we're going to talk about if-then statements. So we're going to actually first open up EBasic Help and just show you some information about if-then statements. If you type in if, you'll see automatically if-then shows up. This is a huge article kind of talking about ways that you can use conditional statements. So in a nutshell, basically an if-then statement is used if you want to compare a response given or something like that. You could say if the decision is 1, then set a trib and then do something like that. So it kind of checks if some response is given, then what's the next kind of portion or conditional thing that should happen. And else if then is another comparison, and the else if actually deals with the multiple conditions. So it'll end at you have to put an end if at the very end of it, but it'll basically go through many different, it'll check the if then, it'll also check this else if. And then if you have an end if at the very end, you'll see there's an end sub here. You have to have an end if in order to end the comparison, basically. And if you don't have that, you will get an error. So you want to make sure that you have an end if, or it won't compile correctly. So we're going to kind of do that in this experiment. So first we're going to type the instructions, of course. So we're just going to throw a text display here and label that instructions. And we'll just type welcome and type any key to begin. So then you can set the instruction slide, you can just add a keyboard and keep it at any, so that they are able to just press any button. And of course I want pre-release to be 0 because we are going to have some scripting. And then we're going to add same thing, the block list, and do our levels that we've been doing. I'll call this block proc, and then I will open up my block procedure and I will do trial list. So the reason we kind of don't have this already formatted for you guys is so you can follow along. And I'll do yes for trial procedure. Now for this we're going to do a wait of 2, and we'll just leave it at trial proc like that. And then we're going to actually access the trial procedure and add a fixation, of course. So it's similar to the setup we've been doing. And then after the fixation we're going to have a stimulus, a decision task. So this is a little different because we're of course using an if-then statement. So we want to compare something. We want them to give a response, and then we're going to look at that. So the decision slide will let the participant know, press 1 if you like cats. I didn't mean to capitalize that. If you like cats. And then we'll do press 2 if you like dogs. This is the question. I guess most people like one or the other. So these are the instructions on the decision slide. So I want to make sure that they are able to press 1 and 2. So I'll do keyboard, and then we'll just have 1 and 2 as the allowable, and we'll set same as pre-release to 0, and we'll hit OK. Now we're going to have a message text as well, and that message text, we'll call this message object, and in this we're going to reference the attribute message text. If I can get there, message text. And you might be wondering, this attribute is not in our attribute list. If you go to view and attributes, there's only session and subject set so far, and we haven't set it in our trial list. As I mentioned before many times, you can actually set an attribute in script, so that's what we're going to do. And we're going to now add a change text inline, and that will go right before the message text. So they'll give their decision, they'll press 1 or 2 if they like cats or dogs, and then we want to change what is shown to them here depending on what they press. So to do that, I'll drop an inline after the decision, so they've given their response, and now EPrime is going to kind of check that and do something with script. So placement of inline is very important. As I mentioned, if you're customizing or changing a font or color of the object or something like that, it would go before the object so that it changes that accordingly before the object is shown on the screen. But if you're actually doing something with the response, or doing some calculation with the responses or anything like that, it should be after the object or after the response has been given. So this will be called change text, and we're going to open that up and of course write our, and I forgot to save, which is bad practice, so I want to make sure I save this, and I'll call this, let's just call it if then. So this if then experiment, we're going to now state that we want to change the text that will appear on the message text display depending on participant's choice. Okay, so hopefully I don't have any typos. I know I typed that pretty fast. And of course we also want to make sure that your trial procedure properties under the Common tab have generate PreRun set to before object run. That's just another important, I know I keep harping on it, but a lot of times we get people that have problems with their experiment and it's just that property that's throwing it off, so you want to make sure it's set correctly. So if the participant pressed 1 during the decision, then make the text say you like cats. So to do that, we're going to do if, and we're going to use an if then statement. We'll do decision, so we're actually referencing the decision object. We've done this before to change the text, but now we're actually going to just check what was given, and when you hit dot, you can actually access the response that was given to the object decision slide. So decision dot response, we want to know what the response was. If it equals 1, then we're going to let EPrime know that you actually have to set an attribute of message text. So this is where we're creating, we were talking about how there's no message text attribute. Well, this is now where we're actually creating that attribute and setting it. So we're going to set message text to say you like cats. So the slide asks you, the decision object asks if you like cats, press 1, if you like dogs, press 2. So we want to put that if then statement there to check that statement. Now we're going to do if the participant pressed 2 during the decision object, make the text say you like dogs. So for that we will do else if, which means that if if 1 is not pressed and something else is, so let's say the decision.resp is 2, then you're actually going to set the attribute of message text, which now is available because we've set it before in the above lines, you like dogs. And then of course you need an end if statement, because if you notice, if I generate this without the end if, you will get an error message that the following error occurred, you don't have an end if. EPrime needs to close out this conditional statement or it will be very confused. So I'll just add an end if there, and then when I generate it now, you'll notice it's run successfully because I had that end if to close it out. So a lot of times we'll get people with a ton of if-then statements, and then at the very end they get an end if, and they're confused. It's because you want to make sure every group of texts that need an end if have one, because you'll keep going, and often some script needs multiple end ifs, and you might be missing one, and then you'll get an error message. And then of course we want to, on our session procedure, just drop a goodbye slide just to close out the experiment, and we'll just say thank you and goodbye. So this is just a very basic conditional statement of showing an if-then. The thing I want to kind of mention is the operators that are used. If you actually are using an equal sign, as I mentioned, it can be assignment or it can be equal. We have actually an article here about the operators in EPrime and operator precedence, which means the order that it's accepted. But these are the operators that are there, and there's some information as well. But the ones that are very kind of common, you can use greater than. So if we actually use it here, so if your decision is greater than 1, which would probably be 2, I guess, you could do that as well. The other one is less than, if the decision is less than 1. If it's equal to, so this is different than assignment. This is actually doing math where it's saying, is the response equal to 1? You could also do greater than or equal to, or you could also do less than or equal to, or you could also do does not equal to, which is this. So those are the different operators, and they are covered in EBasic. So there's a lot you can do with your if-then statements. The other things you can also do are and. So if the decision.resp equals 1, and let's say we added and decision.resp does not equal 2, so that it'll look at both of those things as well. Or you could do or. So this will actually, an and basically returns true if both the expressions are true. Of course, or is a comparison, so it'll only return true if either expression is true. And then you can also do this, which will basically return true if only one expression is true, and it's false if expressions are either both true or both false. And that's covered in EBasic as well. But for us today, we're going to do if decision.resp equals 1, then show this text there, and if you chose dogs, it'll show this text. So this kind of checks for that. If-then statements are very, very common. A lot of times users will do, if the decision is 1, then jump to another portion. There's a lot you can do with this. So I encourage you to go ahead and generate as well as run this experiment. You can pick if you like cats or dogs, and then it'll show you the message text according to what you pressed. So that's the way to use an if-then statement. So now we're going to go back to our slideshow and talk about the topics we just completed. And with the conditional statements, we did cover just the first portion of the if-then statements. And you'll see that if-then, as I mentioned, conditionally execute a statement or group of statements. If it's else if, it'll do multiple conditions, it'll check, and then it'll have an end if. So you can do if-then, else if, you can mix them up as well, and those comparisons can also just use else. You don't have to necessarily use else if-then. And then the end if is important, so it will get that error message. You need the end if to close it out. And then I talked about the logical operators. So this is available in the slides that we're giving you, so you can reference them. They're also in EBasic Help. These are all the different things that you can use for comparisons and scripting in EPrime. So the next thing we're going to talk about are loops. As I mentioned, this is a little bit more of the advanced side of the webinar today. And I'm actually going to base the next experiment off of the setup we have. So instead of having to type it all over again, I'm going to keep this setup. But I am going to talk about loops first. So if you go to the EBasic Help that I keep referencing and type in loops, you'll see there's quite a bit of information about the do loop, and this shows the syntax. And it basically it will repeat a block of EBasic statements while a condition is true or until a condition is true. So that's what this do while these loops will basically keep generating in the background of EPrime until a certain thing is met that it's looking for. So an if-then statement kind of just looks at black and white items, like, okay, if 1 is pressed, well then this is going to happen. If this happens, this is going to happen. A loop will actually continuously do something. Let's suppose you keep wanting to show an image of a cat until they press 2. Well, that loop will keep letting EPrime show the cat until that condition has been met. There's several different types available. The do loop repeats the block of code until a condition is true and then executes an end do statement. So you should always have an end do, kind of like an end if, close out the loop as well. The other one is do while loop repeats. This repeats the block of code only while a condition is true. So while something is true, like if the object is on 100 millisecond duration, continuously show pictures of cats. While that loop is going, it will continue to show cats as long as that is a true fact. Then do loop while executes the block of code once and then repeats it until the condition is false. And then the do until loop is also in there as well. So there's quite a bit of, you can look them up in here as well. And then I have a actual slide that kind of helps explain what I just went over. And that would be the loops here. So the do loop, if you do this one, as I mentioned, it repeats a block of code until a condition is true. So do until somebody presses 1. It'll keep looping until that's met. The do while loop repeats the block of code only while a condition is true. So do while the participant is pressing 1. The do loop while, I know this sounds similar, but this actually does the code and then repeats it until the condition is false. And then the other one is the do until loop, which basically repeats only while the condition is false. And then the last one is do loop until, and this actually executes the code and then repeats it until the condition is true. So there's just a few different things you can do. Today we're actually only going to use one, obviously we're going to put one loop in there, and we're going to actually use the do until loop. So it'll make sense more when we actually type it out. And for that, I'm just going to actually change the decision in this. So as I said, we're going to keep this similar, but we're going to do something a little bit different. We're going to do press 1 if you like, if you prefer red cars, and then press 2 if you prefer blue cars. So what this is doing now, we're still going to have the allowable here set to 1 and 2 because it's, they're allowed to press 1 or 2. But we want to change the text here, so we're going to actually delete what we have. But we're going to now basically change the text that will appear on the message text display. So similar to the last sample we just did. Depending on the participant's choice, so similar, and if the participant pressed 1 during the decision object, then make the text red cars. So similar to what we did before. So we're going to do that. We're going to do if the decision dot resp. This will probably make perfect sense to you guys now because we just went over something similar. If it's 1, well then we're going to set the attribute of message text, which is for that slide, to say you prefer red cars. And then the next thing we're going to do is actually make red car fans wait an additional 3 seconds. So this is where we use the loop in here. And then you also want to first clear the screen. So we want to clear the screen after they've given a response. So decision.clear, and you'll see that's available as a response, and it says here it clears the contents of the defined display area. So you want to clear that decision screen, and then we want to next we're going to define a temporary variable to track time. This is a very common thing. We do have sample experiments that track time and talk about clocks and EPrime and things like that. So to actually define that variable, we're going to do a dim statement, and we're going to do start time as a long, so we can do math and not have to worry. It's important to use a long here because we don't want to have to worry about timing and going over the range. We want the range to be pretty large, so this data type is the largest in terms of whole numbers. And then we're going to do assign the current time to start time. Now, EBasic does cover a lot of information about clock and timing, because it's something that a lot of people want the actual current time. So there is a way to set the current time, and it'll register, kind of track it with your computer. So it'll check the clock on your computer to do that. So we're going to actually use this start time equals clock.read, and you'll see the clock object here brings up a list of things you can do with that, and I'm going to do read, which means it's going to get the current time for you. And then finally, loop until 3 seconds have passed. So a lot of times people want to put a specific time in their experiment in terms of what is going to be generated and when. So here we want it to continually run this script until 3 seconds have passed. So that's why we're using do until, and we're going to do until the clock.read is greater than the start time. And you'll notice I'm using the parentheses to make it easy for EPrime to kind of follow this comparison. It'll gather the information by following the operator precedence of what should be registered first. And then we want to also leave some rest time in the loop to give the computer, to give the computer a pause. This is also another important thing for EPrime when it comes to loops. If you imagine this do until loop is going to continuously run in the background until 3 seconds have passed, and sometimes loops are really big. They check timing as well as duration as well as a bunch of different stuff. So having a little tiny 10 millisecond sleep statement in there is really helpful for timing. It lets EPrime catch up. It lets the loop run smoothly. It's kind of giving your computer a little breather. And then we're going to put the loop in there. So do until loop. And then we're letting EPrime know if the participant pressed anything except 2 during the decision object, then make the text blue cars. Because in the beginning we talked about if the decision is 1, they prefer red cars. So now we need to show, and to do that we'll use an else statement, meaning, and you'll see how I've done the indentation, that this if-then statement is corresponding with this else, and then inside of this if-then there's a loop, but the way that you write it kind of shows which script goes together. So else c.setAttrib the message text to you prefer blue cars. And then of course we also want to put in a go-to statement. So the blue car fans will skip the red car object, and I'll explain that in just a second. So for that I'm going to do go to before message. And then we need to do our end if to close out this statement. So I want to generate this and make sure that the script is written correctly. And I have missing something because I haven't added it yet, but I'm going to now add actually some things. We've changed the text in order to display whether we like red or blue cars. Now, if in your materials you should have gotten an actual image of a, let me find it, but you should have gotten an image of a red car, I believe. So here's the red, drag it to my desktop. Okay, so there's an image of a red car you'll see on my desktop, and you should have gotten that with your materials. So with this, you're actually going to have a red car image right before the message label. So on the trial procedure, I'm going to drop an image slide right here, this image display, and right before the message label, I will drop this little red image of a car, and I'll call it red car. I'll open that up, and I'm going to add the image file name from the desktop. So you'll see there's a red car, and it's BMP, and then I want to just make sure it's centered, and then I'll do 100% of the screen. So this file that we gave you is just a picture of a red car, and then I want to also just make sure that the duration, we'll make it a little bit longer. We'll do it for 3 seconds. So we'll do 3,000 milliseconds, and then I don't want any pre-release to mess up, so I'll hit 0. And then I'll also have a before message label. So I'll take a label object. If you're not familiar, this allows you to jump from different places in EPrime. So I'm going to put a label there, and I'm going to call this before message. So what this is showing is, if you remember, EPrime is checking if they press 1, then it's clearing the object of decision, and it's letting EPrime basically run 3 seconds, so 3,000 milliseconds, and once 3 seconds have passed, it will basically, it'll make the people that press 1 wait those 3 seconds in order to kind of clear the screen, and then it'll show them this picture of a red car. Now if they press, this else if statement, if they press you prefer blue cars, and they don't press 1, it will actually skip. So it's going to skip the red car object. And this is the other thing in addition to loops that you can do is go-to statements. Go-to statements allow you to jump from one portion of your experiment to another. So in this, we're going to jump past the red car image. This red car will not be displayed to the people that select blue cars, and it allows you to jump to this label. The label doesn't really show anything on the screen, it's just kind of like a placeholder, and it'll allow you to jump just back to the message slide and show the message that you like blue cars. So they won't get that image of the red car. So like I mentioned, the go-to labels, they allow you to jump out of the current script to a label wherever you place it. It is subject to scope, so you can only jump in that certain block or procedure. You can't jump outside of this particular block. And you call it label A or label B, or here we put a very specific message before message as the name so that we know what we're referencing. But actually, if using a loop statement, because as you saw, there's so many different things you can do with loop, we actually prefer, it's actually better to use loops over go-to statements, because you'll see that there's a lot of script readability. There's a lot you can do with loop in terms of scripting. Here we've actually set a start time using the current time and having clock.read in this loop statement, and then we're actually checking the current time and getting a value. So there's some math you have to do in there in terms of adding the time. So a loop allows you to do a lot more, whereas a label just allows you to kind of jump around. And we do have a conditional statement, a conditional branching sample experiment on our website that shows all these different methods in greater detail if you're interested in that. So I know we covered a lot. I'm going to actually save this experiment And as I mentioned, this is a little bit more of the advanced experiments, but it goes over some very important concepts. And you'll see that when I generate now that everything's in place, I get that it ran successfully. Because I have my nice end if statement there to close it out, that goes with the if then there's a loop in there, so the do until loop. It'll basically continue to loop until 3 seconds have passed, so that clock will check that. So definitely run through that sample experiment as well. There's a lot of interesting things that are in place there. And as I mentioned, with the loops, there is quite a different ones you can do. The one we did today was do until loop. So it's going to repeat the block of code while the condition is false. So while, until that time has passed, it's going to continue to run that. And then the go-to statements, as I mentioned, you can jump out of your current script to a different label. You have to keep in mind the scope. You have to jump within the procedure. And then you can go to a label in the GUI or in script. So you can actually use the interface by setting jump. So this is something I didn't mention, but if I go back into my script, there is a way in EPrime, in the actual interface, if you see here, that you can actually have the end action. Let me show it on the decision slide. But if you go to here and instead of terminating the object, you can select jump. That allows you to jump to the label, and you could put the name of the label here, which was before message. So that's a way to just put the label in the actual interface. But of course you can set the label in script as well by just saying go to this label, and we put, if they press something different here, go to the blue label. So that is one of the other ways that you can do that as well. So we are wrapping up this webinar. I just wanted to mention, as I did before, loops are preferred over go-to statements because there's more you can do with script in terms of loops, such as adding time and different things you can check with the loop statements. I have some final points here. I know I went over quite a bit of information, but some takeaway points are the differences between variable and attributes. As I mentioned, variable holds temporary values, and an attribute actually will log information to the data file. So these are the comparisons. And then we initialize the variable with a dim statement, and with an attribute we can actually set that in a list or using the setAttrib command. Scripting terminology is important, especially if you're planning to be script intensive with your experiment design. Properties basically store information regarding the behavior or physical appearance of the object. So we talked about referencing text, referencing font, referencing quite a bit of information. Now methods allow access to routines. So this is a code that is pre-written to perform an action. So with methods you can actually do a command or a function. A command will allow the object to do something. So if you want to command the object to do a trial or run a trial or run stimuli, there's commands you can do with that C context. Function will actually return a value. So these are covered in EBasic if you want to look into that. And I also, as I mentioned, make sure you reference EBasic Help for scripting help. Make sure you set pre-release to 0 on objects where there is script involved. And of course, make sure generate PreRun is set to before object run for the property procedures if script is involved. And of course, you can check out our website. We do have knowledge base articles as well as samples on there. We're always happy to help, so definitely check out our website and send us a support request if you have any questions. We will be updating our webinars for purchase, our recorded webinars, so keep an eye out for that as well. Thank you for watching this presentation today, and hopefully if you have any specific questions about scripting, you can be in touch with us at our website at pstnet.com.